Yep, camera on everyone. Let's start with a question. The last thing we are doing was RC circuits. So we have two circuits here, C1, R1 connected to a battery V, C2, R2 connected to 2V battery. Now in both the things, both are charging circuits. This is the current versus time graph. This is the first circuit, I1. This is the second one, I2. So seeing this graph, you need to compare C1, C2, R1, R2. Meaning which resistor is bigger, R1 or R2? Which capacitance is bigger, C1 or C2? This is an IT graph for the charging circuits. Both the graphs start from the same value. Get this? It's an easy one. Let's see. First thing you can clearly see at T0, capacitor behaves like a wire. So current I should be V by R. You're saying both of them have same current, so V by R1 must be equal to 2V by R2. So from here we are getting R2 is 2 times R1. Therefore, R2 is greater than R1. Clear? Right. You can clearly see R2 by R1 is 2, which is greater than 1. So R2 is greater than R1. What about the capacitance? Now, if you look at the capacitances here, look at this thing. In one time constant, the current will become 0.37 I. That means for this guy, this is the time constant. For this guy, this is the time constant. So we can clearly see here, tau1 is greater than tau2. Time constant is the time taken for the current to become decay by 63%. And what's the time constant? R1 C1 is greater than R2 C2. And here another relation between R1 and R2 here. How much is that? So R2 is 2 R1. So C1 must be greater than 2 C2. Clear? So C1 is greater than 2 times C2. What else can I say from here? R2 is 2 R1, R1 cancel. If C1 is greater than 2 times C2, is there any guarantee C1 is greater than C2? Not
Yes,
necessary.
sir, obviously.
नहीं क्यों होना चाहिए? Let's say
So C1 by C2
C2,
is greater than 2.
let's say C2 is 1 point. Mm,
So C1 by C2 is more than 2, which means it's obviously more than 1 now.
yeah. Yeah. Ishan is right. Clear? Next thing. Yeah, obviously. So that's a simple one. And because we know R1 and R2 ka value, if R1 R2 are not known, we wouldn't have got it. Okay, good. So that is some of the things on RC circuit. If you see last class, I sent you a sheet on RC circuits also, and some circuits also. So those who wanted additional practice, you can do that. Next thing. So till now we dealt with all ideal batteries. So in ideal batteries, you had what do you call it, zero resistance and all that stuff. But let's say non-ideal batteries, you have the main ones. So in non-ideal batteries, due to the materials used in the construction, so no matter how well you make it, there'll be always some resistance. There is an internal resistance. Now, what do you mean by that? So whenever you take a battery, the battery comes with a resistance together. So we represent this with EMF, and this is smaller is the internal resistance. So this smaller, right? You cannot remove that. It is always part of the battery. It just behaves like a regular resistance. So whenever someone asks you what is the potential across the battery, this is across this both of them together. You cannot say I will put the battery here and between. You can't do that. You cannot separate it. It is there inside stuck. So this is A and this is B. So whenever they say potential difference in this case, if I is going like this, we have VA minus VB is E minus IR. This is the potential difference across the battery. So whenever you're trying to measure a potential difference, this is what you're measuring. You're not measuring EMF. So EMF of a battery is different from potential difference across the battery. If the current is zero, then both are equal, but technically both are not the same. This is not EMF. For example, let's say we have an internal resistance, we have a battery, 2 volt, and let's say this is 1 ohm, and you connect this across a 3 ohm resistor. So this whole thing comes as a package. So when you want to find the current, it behaves like normal resistor, series, parallel, everything it works. So that would be 2 by 4 ohm. So that is half ampere. Now, if someone tells you to find the potential difference across the battery, that would be 2 E minus IR. In this case, that is 2, I is half, and R is 1. That is actually 1.5 volt. So even though the battery is technically 2 volts, in reality, it is giving only 1.5 volts. So this is what actually happens. So when you take more current from the battery, the lesser the voltage it shows. Even the battery shows 2 volt, we get only 1.5 volts across it. Now, in case of if you see here, the more current you take out from the battery, the lesser the voltage across it. Now, did you ever notice this thing? Whenever you start this thing, whenever you start your car, or ever happened to you in the house, the refrigerator suddenly switches on, or you switch on the mixie, the lights dim for a moment. Did you notice that nowadays it doesn't happen much? You guys live in Mumbai, but normally in villages and all, it does happen, right? Or best example is your car or your scooty. When you start your car or your scooty, your light dims. Car to observe kiya hoga. When you switch on the car, the headlights of the car dim and then come back to normal. Observe that. Why does that happen? Again, same reason. So what happens during the car ka ignition, right? You take a lot of current for a small time. So this is what happens for a car ka battery. You have a car ka battery with some internal resistance. So in this, the everything in the car is connected in parallel. So your headlight is there, and so there is a switch here, and this thing R2. Let's say this is small r, this is some R1, and this is some R2. So when the switch is closed, this is what happens. So when you're starting that ignition, you're actually closing a circuit. You're charging an inductor and you're discharging it. There is a process. So ignore that. The thing is, you're connecting one more resistor in parallel. So initially, only this much current I is flowing. Let me do one thing. Let me take equal numbers. Let's say this is R and this is also R. So initially, current will be E by R plus R. And then the potential difference would be how much? VA minus VB, that would be simply IR. You can just take I into this thing. Now, the moment you close the switch, now both these resistors will become parallel. So this becomes R, this becomes R, this is small r. Now this guy gives you a different current I dash. Now I dash becomes E by R plus R by 2. So I dash increases. If I dash increases, uh, this thing now numbers are becoming difficult to see. Let me give you some values that is better. I'll do one thing. I'll just keep it simple, even though it is not right. So this is I1, this is I1. Now let's say the moment you close the circuit, let's say this becomes I1. This is not exactly right. So here the current becomes I1 plus I2. So now what happens? VA minus VB, this will become EMF E minus So basically, you're pulling out more current from the battery. Because of that, the potential drops. If you actually put values in C, you will find it will become less. So due to increase, so whenever you keep something in parallel, the overall resistance decreases, so current increases, right? If you pull more current from a battery, E minus IR, that I will increase, the overall thing will drop. So due to increase in current, the potential across the battery drops. So when you start the car, let's say the bulb is taking around 0.1 ampere, the car ka engine will take around 10 amperes. It takes a large current, but for a short time. So suddenly the voltage drops. If the voltage across the battery drops, then the bulb will be dimmer. Bulb becomes dim. So technically I1 also won't remain same, but okay. Clear with this? So same thing. Reverse also you can do. You can even charge a battery also. That's what you do with your phone. So if you're charging your battery in this scenario, the current is going into the battery. So they can ask a question like this: can the potential difference across the battery be greater than EMF? Equal to EMF, less than EMF, all are right. VA minus VB in this case is E plus IR. This is the charging of battery. So don't get confused between EMF and the potential difference across the battery. So the current comes out of the battery is discharging. If the current goes into the battery is charging. Do have a look at this page. And generally in the house and the vehicles, the circuits are connected in parallel. So the more circuits you connect, the more current it draws and the potential drops across the whole circuit. So that 1.5 volt battery which you see, when you put it in a car or something and you're playing, if you see that it gets exhausted in like half an hour, 45 minutes. After that, if you take the same battery and put it in a watch, it still works. Because battery doesn't need so much current. Battery needs a very minute current. So the battery which doesn't work in that place, the car or something, it works in that. One of the reason, right? We can literally see that watch ka battery literally goes for months. But that car ka thing, if you play morning to evening, I think 1.5 hour will exhausted. That too, you don't keep one battery. You keep like 4 or 5 batteries in it. Never played with that? The remote control car. What do you thought? You thought real car. Real car, they have to go and see Tesla. They do actually have batteries. If you see Tesla ka main battery, right, the car ka, it is actually made of single cells. So if something gets spoiled, right, you do not replace the whole thing. You just replace those cells and it is back to work. Clear this? Great. Then, so if you try to plot this, EMF, so small resistance R, this is capital R, and this is I. So VA minus VB is equal to E minus IR. So if you see this graph, this is minus IR plus C. This is a straight line. Y is equal to MX plus C. So if you plot a graph between the potential difference versus current, you have a straight line with a negative slope. So this value here is your EMF. This occurs when R is 0. Means if you connect the external resistance to be 0, that means you short the battery. Then the potential difference is 0 and the EMF is potential difference is equal to EMF. At this point here, I think I'm saying reverse. This is R infinity. This occurs when R is equal to 0. If you keep R is equal to 0, it gets shorted. The potential difference is 0 and the current is E by R. And if you keep R is infinity, the circuit is open circuit. The current won't flow. So if current is not flowing, potential difference is equal to EMF. So this was asked in the exam, mains mein. They asked a question like this. They said the potential difference delta V versus I का graph is given. They gave the values like this. This is 2 ampere and this is 10 volt. The question was find internal resistance of the battery. So here, if you look at this, when I is 0, delta V is 10 volt. When I is 0, EMF is equal to delta V. That is 10 volt. When delta V is 0, that means the battery got shorted. You can't short an ideal battery. You will get sparks and there will be infinite energy flow. Technically, not possible, theoretically. Current here will be E by R. So this is 2 ampere, this is 10 by R, so R is 5 ohms. This was a mains question. Have a look at this. So that is a little about a non-ideal battery. So a non-ideal battery comes with a resistance and the voltage doesn't remain constant. It depends on the current. Clear? Next thing. Combination of cells. So what happens if you keep these cells in series or parallel? The first thing, series. So E1, E2, E3, En, R1, R2, so on till Rn. I can just combine all of them into one resistor and one battery. This is R equivalent. This is EMF equivalent, which is sigma EI. R equivalent is sigma Ri. Now in this, there was a question like this in the exam. So there are n identical cells. And a student accidentally connected. So we have n cells like this, all are identical. Connects m cells in reverse polarity. Instead of keeping all of them in same polarity, m cells were in reverse polarity. Then what happens? What will be the equivalent EMF and equivalent resistance? This was also a question in the exam. Yeah, it's a standard one. Now, if you see here, there are m cells in the opposite, and these are n minus m cells. So you need to understand something. First of all, you lost m cells, and those m cells were in reverse direction. Think of like this. In your team, if there are 10 gang members, and in my team, there are 10 gang members. If two members leave your team and come to my team, what is the difference? It is not 2, it is 4. You lost 2 and I gained 2. The same way here, first of all, you lost m batteries, so EMF is n minus m, right? And then the m batteries which got reversed, they cancel another m batteries. So this thing can be replaced with, this will be nr and this will be n minus 2mr. So be careful with that. Easy question, but yeah, n minus m e. Next one is all theoretical things. What happens if you keep them in parallel? Any doubt so far? Why are so many people missing today? Almost 3 people are missing. Let me just take a photograph and send it to Vimima. She'll call them off. Next one. Cells in parallel.
So could you go back for a moment?
Done? Cells in parallel. What happens? You keep n cells in parallel, E1, R1, E2, R2, En, Rn, and this is capital R. So we'll assume all the cells are giving current. I1, I2. If something is going in the opposite direction, science will take care of it, and this is capital I. So I is nothing but I1 plus I2 plus so on till In. So apply Kirchhoff's law through the first battery and the capital R. Then apply Kirchhoff's law in the second battery and the capital R, and so on. If you write these equations, you get E1 minus I R1 minus I capital R equal to 0. From here, you get I1 is equal to E1 minus I capital R by R1. Second batteries, if you go, E2 minus I2 R2 minus I capital R is 0. Now, if you do this so on, you end up with En minus In. This is In minus IR equal to 0. This would be N minus IR by Rn. Now, if you add all of these, I1 plus I2 plus In, on the left-hand side, you'll get capital I. This will be E1 by R1, so that will be sigma EI by Ri. And that would be IR sigma 1 by Ri. You can rearrange the terms. You will get I is equal to sigma EI by Ri by 1 plus R into sigma 1 by Ri. And you want the potential difference across this. So VA minus VB will be IA into capital R. This would be the current in that external resistance R if you have N batteries. There. So this is actually the potential difference across all the batteries. Clear, everyone? Now, this thing, if you have multiple batteries, it is fine. But if there are two batteries, we get a decent result. So if you mug it up, it is better, saves you time, especially for mains and bits. If you have only two batteries, E1, R1, E2, R2, you're connecting in same polarity. You can replace this with a single battery.
So I connect with the previous formula.
And like this would be your R equivalent, and this would be your E equivalent, where E equivalent is E1 R2 plus E2 R1 by R1 plus R2, and R equivalent, they behave both are like in parallel. So you can replace that both the bunch of batteries with this. There, have a look at this.
EI by RI, the sigma is whole, right?
किसका?
Per numerator.
हाँ, ये पूरा होल है ना.
So what is the formula for E equivalent for N cells?
There is nothing.
Oh,
There are questions like 3 cells is find E what to be doing.
Then just apply this formula multiple times. Problem देखो ना, if you apply 3 cells, 2 cells में you got E1 R2 E2 R1. If you have 3 cells, you'll get E1 by R1 E2 by R2 plus E3 by R3. You don't get such a beautiful thing. You'll get something pretty weird. You'll get then E1 R2 R3 E2 R1 R2, something like that.
Yeah. So is it not like the resistance even R2 to R2?
No, it is not like that. This thing actually we got from here only. Right? We can simplify it for 2 things, but 3 things, so this is the general formula. So you want to apply for what? 3 cells, then this thing is coming, na? The potential difference is I into R. You can't replace the whole thing with one battery and one resistor, if that's what you're asking. I think at least I am not able to simplify this. You simplify this and tell me.
so simplification, I know it'll be messy, but even then we should be able to replace it now. So why
Yeah,
can't we
yeah,
replace
yeah.
it?
So replace kar lena. Where am I stopping you? Replace kar lena, get 3-4 terms ka thing. I'm fine with it if you can by heart that formula. For 2, it looks neat and nice, nothing much. That's what I'm saying. If you put 3 batteries, it'll be E1 R2 R3 plus E2 R1 R2. Then what will you do? So you can do that. Then someone will say, do it for 4 batteries also. So you can keep doing that. So let's just keep it for simple 2 things. It is fine. If there are more than 2 batteries, you can do this. Or actually, if there are more than 2 batteries, 3 batteries are there. First apply for 2 batteries, then apply for this and that battery again. You can keep on replicating it. So if you are in reverse, then, so I'm assuming E1 is greater. The E equivalent would be E1 R2 minus E2 R1 by R1 plus R2. R equivalent would be R1 R2 by R1 plus R2. So remember this much is sufficient for generally 2 batteries. It works pretty well. It's quite useful. And like I said, mains and bits level. Anything more than this, then you have to go back to this thing. The N formula. Let me show you how the last conversion. Next one. Let's see our question. Do remember this, huh? Quite useful. Saves you a lot of time. For example, look at this question. They'll ask you pretty simple questions. Right? Mains and bits, they're not going to ask you something out of the world. But the thing is, you'll unnecessarily panic and you will lose a lot of time. For example, if someone gives you like this. let's say this is 10 volt, this is 5 ohms, this is 5 volt, and this is 2 ohms, and this is 3 ohms. Find the current. And normally, if you want to solve this, you have to use Kirchhoff's law, and you can solve it. You'll get the answer. Assume current I is coming from 10 volt, then I1 and I2, and then I minus I1, and then apply. That same question, but this time it is in reverse polarity. 10 volt, this is 5 ohms, 2 ohms, and 5 volt. This time you connected a capacitor. You can do this for capacitors also. It doesn't matter what device you're using. 2 microfarad. Find charge on the capacitor. There. Get that? So first one, if you look at this, I can replace the whole thing with one battery. E equivalent would be 10 into 2 plus 5 into 5 by 2 plus 5 numbers are bad. That's 20 and 25, 45 by 7. R equivalent will be 5 into 2 by 7. And therefore, the current I would be 45 by 7 by 10 by 7 plus 3. That you can solve it, you get the answer. In this case, the battery E equivalent would be, now if I assume 10 is greater, you're getting a negative value. Actually, 5 is greater here. So 10 into 2 minus 5 into 5, meaning the right side is positive, by 7. This is minus 5 by 7. So the left is not positive, so the battery is actually like this. Meaning this is a positive plate. Q is equal to CB. That will be 10 by 7 microcoulombs. The right side is a positive plate. Clear? So when you say E1, means you're assuming E1 ka terminal is the positive side. If you get negative, means you are wrong. It is not the other one. The other side is the positive terminal. So science will take care of it. So in this case, if you see, even though the 10 volt battery is looking like the strong one, in reality, the 5 volt is a strong one. That has too much internal resistance.
Sir, in B part, at steady state, the capacitor will break the circuit. Now they should be in series only.
So what in series?
The batteries and the resistors.
What are we trying to do exactly, sir? We are
Find
trying
the
to see
charge
how
on the
is
battery.
this, we are trying to find what is this doing to this. Yeah, bas itna hi, okay.
Acha, okay,
I never asked like what are these two doing. These two will be in series, fine, let it be. You're not interested. What are these two? So this thing is acting like, you know what, when R is infinity in a open circuit. You can try that and you'll get the same thing.
I got something weird now, that's why I asked.
Now when you do current, kitna aega? 10 plus 5, 15 aega. 15 by 7 is the current.
Yes, sir.
Then you have to find the potential difference across these two terminals.
So that will be
समझ गया? Then
10.
how much? 10 plus I होगा, IR plus होगा वो. Because
हाँ,
current is
plus
going
होगा.
in the opposite direction ना. How is the current flowing here?
Opposite direction.
No, current is coming out only here. 10 minus IR only.
हाँ, तो
Hmm.
minus होगा. Oh,
Yeah,
मैंने
minus
plus
ही
कर
होगा.
दिया. Never mind.
Current is going in the same direction.
हाँ, yes, the same answer आ गया. I did plus for some reason.
High volt is stronger because of reverse pull. No, it's not exactly stronger low. If you see the product na, even R2 minus E2 R1 na, this product is coming smaller than this product. और कुछ नहीं है. The 10 volt has too much internal resistance. Even though the battery is stronger, the internal resistance is messing up. Clear? So this is still fine. Like this is the kind of question they'll ask you. A simple mains level question or a bits level question. So you know this thing saves you time, and main thing, more than saving time, the moment you see this, you feel really good. Like अरे मुझे पता है क्या करना है, and you will finish all this in 30 seconds, and that will give you momentum. Getting it? It is really important that in the exam that you have momentum, right? You panic and you start messing up because trust me, in the final exam, na, if it is there 3 plus 5, you will think 2 times whether this is 8 or not. You will literally start counting 3 plus 5, 8 hona chahiye, 5, 8, You're getting it? So in that moment, when you are sure, when there's a confidence, here, this is the answer, it helps a lot. Most people don't realize that everyone thinks subject. Subject is one part of the game. You should go to the exam and should not panic. Even if you panic, you should still perform. Someone asked me like last time, sir, if you go to the exam and still panic, then what? I said, see, even on your worst day, you should still score 80% of your best. That is the only way out. You're saying, I don't want to panic. You can't avoid that. That is in your nature. So you know you're going to panic. Now what? So prepare so much, right? Even on your worst day, you're still getting 80% of your best. If it is your best day, you'll get 120% of your best. So that will change with 3 questions. The first 3 questions you get will change the whole thing. That's why I keep saying don't attempt the paper in an order. Find out the easy ones. Next thing, mixed grouping. This I can teach you as a concept and a problem. So let's see that. What if you have, and this is quite important result. If n identical cells are given, R and E are given to be connected to an external resistance, capital R. Now the question is, how should they be connected to get maximum current? Now see, one thing, I can keep all in series. I'll get more EMF, but I'll also get more internal resistance. I can keep all in parallel. I'll get resistance, less resistance. But the problem is, I'll get less EMF also. So the general notion is, this is what we assume. We take n cells in series. Like this, we take m branches. So we need to keep it symmetrical. The idea is this: even if one branch is less battery or more battery, some current will go into that branch unnecessarily. So you have to and let there be m branches and tell you what it means. So you need each branch as n cells, and there should be m branches. Now you're saying this whole thing is connected to an external resistance R. Now, one reason for symmetry, generally, symmetries give maximum thing. But another logic you can say is, if this is giving current I1, this is giving current I. If there is some branch which has smaller number of batteries, then some current may go into that circuit. That means you're getting less current in the capital R, isn't it? So by making all are symmetrical, we are sure everyone is pushing current into the external battery. So N and M, I don't know. So the question is this, find N and M. So basically we'll get capital N is equal to N and M. So find M and N. Try, I'll give you a minute, 2 minutes. This will be the question. They will not give the circuit. I'm telling you, circuit will look like this by symmetry. They'll ask you like this. How many batteries should be in series and how many batteries should be in parallel? We are going to derive a general formula. Example, they'll say there are 100 batteries, this much voltage, this much resistance. How many should be in series and how many should be in parallel? So options will be like 20 batteries in series and 5 branches in parallel. Something of that sort. Let's try this, everyone. You think all are in parallel. What is the proof? Prove it, prove it. Just give me a minute. Any answers? We have to do maximum minimum. There are two variables here, small m and small n. The result is quite important, right? Now all will give same current I. So this will be capital I. There are m branches in parallel. So this is mi. Apply Kirchhoff's law through any one loop. Then you will get Ne minus I times Nr minus capital I R equal to 0. But you don't want small I. So Ne small I would be I by M, Nr minus IR equal to 0. We get I is equal to Ne by Nr by M plus capital R. Bring that N down, you get E by R by M plus R by N. There are two variables here, so just let's replace with any one of them. Let's replace M is equal to N by small n. We get E by Nr by capital N plus R by N. There we have a variable in terms of N. We need to minimize this. so that I get maximum. So differentiate with d by dn, n r by n plus r by n. That would be r by capital N minus r by n square equal to 0. N is equal to root over n r by small r. There. So let me just put on the final answer. I'll show it again. So for this thing, the answer is n is root over n capital R by small r. The m will be root over n small r by capital R. So these are in parallel. These are in series. Example. Let's say n is 100 cells, R is 8 ohms, and small r is 2 ohms. So we get n is equal to root over 100 into 8 by 2, that is 20. So we should keep 20 in series and 5 parallel. Make sense? That formula is very important. Exam, you won't have time to derive this if it's a mains exam. If you can derive, that is also fine. Meaning I can derive this in a minute. So if you can derive that, then it is fine. No need to remember. Meaning the biggest confusion I always have is I get confused between n and m. So I have that problem. Exam, if it comes, I don't have the confidence to remember this because I do get confused between these two. The moment I see this question, I just get to the derivation pretty fast. So at least I remember the derivation, so I skip the steps and finish off in 40-45 seconds. Now in this, something like this can happen. What if you have n is 100, r is 27, and small r is 3 ohms? Now what will happen? Now we get n is equal to 30. Now how will we do? You can't have 30, right? Because m will come in fractions. Now what? So we take the, now if you look at this 100, what are the sequence you can write? So if you write n into m, you can get this as 100 into 1, 50 into 2, so 50 in series and 2 branches, 25 into 4, 20 into 5, 10 into 10. So if you look at this, when you say n is 30, the closest sequence is this, isn't it? This is the closest possibility. Mathematically, it is saying m should be a fraction, but we know you can't have a fractional battery. This is the closest possibility. I forgot the possibility spelling.
POSSSIBILIT.
Yeah. I had a feeling double B looked so weird. So this is the closest possibility. So the answer should be n is 25 and m is 4. Because you can't have m in fractions.
So in this case, if we don't make the circuit symmetrical, is there any way to prove कि it'll be better than this?
बहुत complex हो जाएगा, नहीं कर पाएंगे.
No,
So
that's why.
generally they shouldn't touch this case, they won't touch. But if at all they ask you, we will expect this is the thing. Prove नहीं
Okay.
कर पाएंगे ना. How many possibilities will you take?
We'll have to take everything generalized. N1 and 1
So
branch,
we
N2
will
second branch.
assume, mathematics is saying if you take 30 and 3.3 is the closest, the thing which we have closest is 25 into 4. So we'll assume that is the best thing.
Okay, sir.
All clear with this? Do have a look at this thing. The result is very important. So you definitely have to mug it up. All clear with this? Try the page. The result is this. Have a look at this. Great. Next thing. Power produced in a resistor. So that's about combination of batteries. So if you have a resistance R, I is the current. So power is simply, if you actually see, power is dW by dt and work done is nothing but V into dq. If you divide by time, you'll get current. So V into I. This can be also written as I square R. This can be also written as V square by R. Now be careful. Most common mistake, people think V is the battery EMF. V is the potential difference across R. Don't do that mistake. This is the potential difference across R. The heat produced will be integral power into time, which is integral I square R dt or integral V square by R dt. Straightforward formula. Clear? Let's see a question. Turn in the page. We have a IT graph. This is 10 amperes and this is 2 seconds. R is 2 ohms and you're sending this current through this. So you have a variable current which is decreasing linearly and you're sending through this resistor. Find heat produced in 2 seconds. Charge. This is charge is T square minus T. Find heat in 2 seconds. Let's get them. Simple calculus based questions. थर्टी टू एट एंड इतना अच्छा आंसर आ गया रे maybe. I hope you integrated I square R dt and I is not constant. And you can't take average, it's I square function. Get them, get them. You got a minute, 2 minutes. It's not, these are not tough, but these are just mathematically here. Just try to solve brute force. Let's see. First thing, it's a linear function, so we need to find that. So I is equal to the slope is how much? -5 t, and a t is equal to 0. Current should be 10. So this guy is 10. I hope I'm right. So I is equal to AT plus B, and then heat is equal to integral I square R dt. This will go from 0 to 2. So that 5 square will come out 25, and that is a 2. So that will be a 50 integral. That would be t minus 2 ka square dt. How much is you getting this thing? This is not area under the graph. Area under the graph will give you charge. So this is how much? 400 by 3, 800 by 3. Yeah, none of you got the same answer, right? 80 by 3, 2800 by 3, 400 by 3, 1000 by 3. Shit, I thought I'll just write it down directly. Like you made me do the work. इंटीग्रेट करो, क्या था वो? फर्स्ट थिंग इज टी स्क्वायर, तो टी क्यूब बाई 3 minus 4t square by 2 plus 4t. Put 2 there, so 8 by 3. That was also 8 plus 8, so 8 by 3. This 400 by 3 joules. Second one. First find current dq by dt. 2t minus 1. Again, same thing, brute force. So heat is equal to I square r dt. 2t minus 1 whole square, r is 10 into dt. This is 0 to 2. How much is this? Someone didn't integrate. वो होता है Ishan. You have to be careful. Last time someone came and complained to me, sir, I solved the question, I got the answer B, I marked C and came. What should I do? I said, like, no, what should I do? Matlab, you come and tell me how to change this. I really didn't understand what to say. Now, if you had told me, right, sir, I didn't know the concept, shall I like teach you? You did calculation mistake, I'll tell you to be more careful. You come and tell me I solved it, I got the answer B, and then I marked C in the exam. What should I do? I said, what to do? Be more careful next time. Someone got 33.33, 90. You solve it. I will leave it to you. Abhi itna to you guys can handle it. Let's see something better. Next one. So we have a container. Identical containers. So in case one, you took two resistors, kept them both in series, and you connected them to a battery. The second case, you connected both in parallel, and you connected to the same battery. So here, time taken to boil the water T1 is 40 minutes. Here, the time taken to boil the water T2 is 10 minutes. Find R1 by R2. Ishan has superpowers. Marking the wrong answers. Let's get this. Hey, that happens because you're not calm in the exam. You're in a hurry. The best way to reduce that is that one I'm saying. If you finish off all the easy ones, and you know in the end what is left is all the tough ones, you won't care. You'll be more peaceful. You'll be more patient. You will be trying to attempt them. And luckily for you guys, it is online exam, right? There's no need to do bubbling. Our time we used to do bubbling also. There's a high chance of doing a bubbling mistake. Someone messed up one thing, whole thing goes for a toss. Let's get this. This is a simple one. These are easy ones. I'll show you some good ones after this. These are like proper mains and bits level questions. Yeah, Lakshika, that is right. Others, get this. I got a minute. One, yeah, they're equal. So in the first case, now see, the time taken to boil the water is same. In both will have same heat. So the heat H will be, in the first case, it is V square by R1 plus R2, that is the power, into time is 10 minutes. In the second case, it is V square by R equivalent, which is R1, R2 by R1 plus R2 into 40 minutes. No, this is 10 minutes, that is 40. Anyway, the minutes will cancel, and units are same. If you solve this, you will end up with, I think you'll get R1 minus R2 whole square is equal to 0. You get R1 is equal to R2. Yeah, they're equal. Clear? Easy one. I could have changed the values of 40 and 10 minutes. I'll get different times also. I can get different values. Next one. Next one. We have a piston here. Adiabatic piston. Area A. Mass M. The entire inner thing is filled with helium gas. This is also an insulated vessel. Thickness D is the thickness of the piston. Thermal conductivity is K. Outside the pressure is P naught, temperature is T naught. You connected a heater here. Basically, that's a resistor. So you're sending current I and this is R. This is a helium gas with N moles. This is also an insulated container. So heat cannot escape outside. Outside is atmosphere pressure P naught and some temperature T naught. Yep. So first question, if the piston moves up with constant speed V, find V. Just get me the equations. I don't think we'll be able to solve this. I need more information. I'll do one thing, wait. First case, it's an adiabatic piston, so let's not take conductivity. Let's get that. Second part, if the piston is conducting, now heat can escape through this. If piston is conducting and massless, and changing the information for the second one. And if the initial speed is 0, find the velocity as function of time. Just get me the equations and leave it. You'll get a lot of variables, I guess you won't be able to solve. Because as long as you get the equation, it is sufficient. I can give you proper values to get an answer. There, heat transfer, thermodynamics. So literally I square is only the current part. Get the first part. Adiabatic piston, so heat can't escape out. It's going up with a constant speed v, find v. So basically, as you're heating up the gas is expanding and it is pushing the piston out. And for some reason, the piston is going out with a constant speed v. This happens only for a particular speed v. How much is that? What is the formula for thermodynamics? PV is equal to nRT. dq by dt is what? Ka delta T by L. Is pressure changing? PV par gamma. Arey God, PV par gamma is when there is no heat coming in, heat going out. यहाँ पे heater है ना? This is not an adiabatic process. Heat is being produced inside. You are giving heat to the gas, isn't it? Just because you see the word adiabatic piston, chalo, adiabatic nikal dete. Insulated piston. Adiabatic piston, adiabatic process are completely two different things. Should I show you the first one? One thing I'll tell you, see. ऐसा सोचो ना, whatever heat you're supplying, where will this go? It is used to push the piston up against the gravity. It is used to do work done against the atmosphere. Luckily, piston ka speed constant, so there's no change in kinetic energy. And it is also going in changing internal energy of the gas, isn't it? So you need to think, where is this energy going? Whatever heat you're producing, where is this going? It is going to the internal energy. It is going to push the mg upward, mgh, and it is also going for atmosphere. And the thing is going with constant speed, so luckily there's no change in kinetic energy. That's it. So try to see from that terms. It's mostly an energy conservation problem. The heat supplied by the heater in a small time dt will be change in internal energy, change in potential energy of the piston, and work done on atmosphere. So let this distance be x. So at any instant, if you apply PV is equal to nRT, now if you look at the piston here, From outside, you're pushing P naught into area. This is mg. This is P gas into area. So this guy will be P naught plus mg by area. Volume will be A into X. This would be NR into T. That is the relation between temperature and X, where X is the length of that air column and T is the temperature of the gas at this instant. Make sense? Now, let's say in small time dt, heat supplied should be equal to change in potential energy of the piston plus change in internal energy plus work done on atmosphere. You're pushing the atmosphere out. So in this process, let the piston go by distance dx. In time dt, let piston go up by dx. So how much heat are you supplying? I square R dt. dt is time. Change in potential energy is mg dx. Change in internal energy is ncv dt. Capital T is temperature. Work done on atmosphere is P naught A into dx. Send the dt that side. You end up with I square R is equal to mg dx by dt, which is actually the velocity of the piston. ncv dt by dt, you want the rate of change of temperature. This also will be P naught A into dx by dt. Here, differentiate on both sides. If I differentiate here with time, you will get P naught plus mg by A into A dx by dt is equal to nr dt by dt. There, I can bring this dt by dt also from here. So I can write this dt by dt is equal to some constant, let's call it z into dx by dt. That z you can calculate, P naught plus mg by A by nr and all that stuff. This guy is P naught A plus mg by nr. Perfect. And dx by dt is nothing but velocity. Substitute here. So this guy would be I square r. This is mg velocity. This is ncv z velocity plus P naught A velocity. So velocity would be I square into r by mg plus P naught A plus ncv z. That is the speed of the piston. Is this clear, everyone? Suppose if I had asked you to find the velocity as function of time t, then I will get one more term, change in kinetic energy. Half mv square ka differential. There I will get stuck actually. You'll get stuck because of two reasons. One, the piston will be accelerating. So this equation you will goof up. Second, change in kinetic energy, you'll get mv dv by dt. I won't be able to eliminate that. So keeping the velocity constant is important. Nahi to this question becomes, you'll get differential equations you won't be able to solve. Have a look at the steps. So left side is ideal gas equation, right side is that energy conservation. All got the steps. Any doubts on this page, please ask me. Yeah, empty this week, right? Or last week it got over? This week, no? Yeah, that is for juniors, I guess, last week. Question abhi tak hua nahi, gods. B part kaisa karna hai? Now the piston is conducting with thermal conductivity K and massless. I made the mass 0 this time, piston ka. Just write the equation. this is also solvable, but get the equation. And if initial speed is 0, find the speed as function of time t. I need to keep it massless, or else again we will get stuck. This is not any regular process, Ishan. It's a temperature which is changing with x, right? It is nothing. Actually, it is a isobaric process. Pressure is constant, na? Because the piston is going with constant speed, there is no acceleration. Pressure is always constant. P naught plus mg by A. It is an isobaric process.
In the next case, it won't be, no?
It
It'll
won't
accelerate.
be accelerate. No, that also will be isobaric process.
So how? It'll accelerate, no?
देखो, तो देखो ना, calculate करो. It will accelerate, but it's still isobaric. Get the equation for the second one, everyone. We can play like this, like just imagine I can keep a soap bubble and I can put a resistor and I can ask you find the radius of the soap bubble. That also would be nice. In that you'll have surface tension, you'll have thermodynamics, you'll have heat transfer, you'll have current electricity. You can play. Only difference in a soap bubble is what? Excess pressure inside will be P naught plus 4s by R. That equation will change. And you can play the same question.
Sir, I don't even know how to start. That means the heat is going in the thing and then it is leaving also.
Yeah. Poor thing.
So we'll have to use Newton's laws.
Yeah.
That radiation was a law.
Radiation नहीं है इसमें. There is only conduction.
Oh.
Radiation के लिए तो I would give you emissivity also, ना? That would be more fun. T power 4 आ जाएगा. You will die. That's why I didn't give.
Thank you, sir.
Let's not get there. Let's see. Same idea here. So, first thing, if you take the piston here, outside the pressure is P naught into area. It's massless, so P gas into area. Mass is 0. Chalo, I agree it is accelerating, but mass is 0. So P gas minus P naught into area is equal to mass of the piston into acceleration of the piston, which is 0. So pressure of the gas is P naught. The pressure is constant. It's an isobaric process. Then, so we get P naught into A into X is equal to nRT. This is your temperature as function of X. Now look at it in time dt. What are all the things that are changing? Change in potential energy of piston, but luckily here M is 0, so that term will be 0. Change in internal energy of the gas, work done on atmosphere, plus heat escaping through conduction. If there's a radiation, then you'll see heat escaping due to that also, but it'll be the same thing. Conduction is fine. Conduction plus change in kinetic energy of piston. So there'll be 5 terms here. But luckily, This term would be 0. This term would be 0 since mass is 0. That's the reason I gave M0. If M is there, it would be quite a mess. So heat supplied would be how much? I square R dt. Change in internal energy of the gas, NCV dt. Work done on atmosphere would be P naught into A into dx plus the heat went away due to conduction. We also know dq by dt is equal to Ka by d delta T. So here delta T will be temperature inside minus temperature outside. So the heat, this will be Ke by d T minus T naught into dt divided by dt. You get I square R is equal to NCV dt by dt, and that is P naught A dx by dt. And this guy would be plus Ka by d T minus T naught. You know everything here. You can find dt by dt from here. Substitute. You'll get dx by dt from here, which is the speed. It is solvable. Just because mass becomes 0, those two terms made your life easy. Or else this guy would give you an equation mg dx. Actually, that is also still fine. That piston is still fine. Kinetic energy would be change in kinetic energy. So that would be mv dv. Acceleration will come. This equation won't come. Many things will go messed up. Taking massless piston saves you a lot of things here. It will become a solvable question. Is this clear, everyone? Have a look at this. There, you can play around like this. Clear? Take a break. Come back by 7:10. We'll have a small break.
If we try to eliminate capital T, we will get an X also here, right? So
Chalo, let's see. Let's see one more. Ishan wanted radiation also. Let's get this thing. This would be a proper advanced question, right? This is seriously pretty good one. You should definitely try this. The previous one still was like a zombie, but this is like a proper Godzilla. So we have two conducting plates. In the middle, it is filled with a medium. So you are connecting a battery like this V. This is grounded, and the outside is also grounded. So current is flowing from inside to outside. This entire region is filled with a medium. The inner radius is A, and the outer radius is 2A. Outside is vacuum. This is a solid sphere. Concentric conducting shells with space between them filled with a medium. Rho is the resistivity. K is the thermal conductivity. So when the current is flowing from inside to outside, heat is being produced throughout the whole thing. E is the emissivity. Sigma A E T power 4, that E. So potential difference V is applied between the inner and the outer shell. Find R equivalent. Find current. Here it is fine. Find temperature of the outer and the inner shell. I can ask you find temperature as function of X, but okay, same thing. In steady state. Let's get this, everyone. This will be an advanced paragraph question. Think for a minute, then I'll tell you what is happening and then I'll give you a little more time. Here, heat is not produced at one place, heat is produced everywhere. And all that heat is going out because of conduction. And then it is escaping to our vacuum through radiation. Others, do keep your cams on. First, find the first two parts. Those are easy. R equivalent and current. Resistant. Yeah, we neglect that. Don't bring so many things. You want that also. Then more messed up. Let's not get into that. Yeah, R equivalent is easy. This though we have done this question. Here it is rho naught X. So for the first part, take a thickness dx. The resistance will be rho L by area rho, length is dx, and area is 4 pi x square. So R equivalent will be rho by 4 pi integral a to d to a dx by x square. That would be rho minus 1 by 2 to rho by 8 pi a. Then the current I would be V by R equivalent. V 8 pi a V by rho. Till here it is great. The heat part is the complex one. Now what is the catch here? Actually, the outside heat is the easiest one. Now if you look at the total heat produced per second, you can simply write V square by R equivalent. Now you tell me one thing, where is all this heat going? All this heat escapes to vacuum through radiation, isn't it? All this heat escapes to vacuum. There is nowhere else to go through radiation. So whatever heat you're generating completely, so if I take T2 is the temperature of outer surface, so all this radiation is how much? Sigma area E T2 power 4. That should be equal to V square by R equivalent. Area will be 4 pi 2a whole square. Simplify this, you'll get T2 from here. Is that making sense? There is no way for the heat to go. All the heat which is produced must go through the outer surface to infinity. Through vacuum, that is the radiation. How will you find the inner temperature? Sigma 4, वो है ना रे, Stephen's constant, 5.678, 10 power minus 8 thing. This is the radiation emitted per second. Sigma AE temperature of the body power 4 minus temperature of the surrounding power 4. Don't forget that radiation ka tha. How will you find the temperature of the inner surface? Think. So if I have to ask you this question, I'll ask you this only. Find temperature of outer surface, inner surface. Outer you can still find. Inner is not that straightforward. You can use current, but how? Who will have more temperature, inner or outer? That is also difficult to. How will you guess this? Because यहाँ पे problem क्या हो रहा है ना? The heat is not constant. See, current is constant. Heat current is not constant. Look at this. When you took this region here up to X, this dx, so this is what is happening. All the heat that is being produced from A to X, all this heat, that heat is flowing out, isn't it? The heat flowing through the dx section, it is not produced at one single place. Heat per second passing through dx is all the heat produced from A to X, meaning the more you go out, more heat is coming out. So at every instant, the amount of heat flowing per second is changing. It is not constant. You're getting it. Regular current is constant. All the heat produced from A to X is flowing through dx. Is that making sense? So what is R equivalent then? A resistance up to X. So resistance up to X, in this formula, rho by 4 pi integral dx by x square, limits will go from A to X. This would be rho by 4 pi 1 by A minus 1 by X. So what is the heat produced per second up to X? That would be I square into, I'll just call it Rx. So now conduction formula. dq by dt is equal to minus ka dt by dx. This is a conduction, non-steady state basically. Every instant heat flow is not same. Now dq by dt is this guy. I square Rx, which itself is depending on x, is minus ka, area is 4 pi x square, and this is dt by dx. Shift everything that side. You'll get dt is equal to minus I square. R would be rho by 4 pi 1 by A by 1 by X. This is not good. Dx by 4 pi x square. And then integrate this thing. So dt limits will go from T2 to T1, the inner surface. And this side, all this thing integration will be limits T2 is from 2A to A. And if you solve that, you will get T1. Yeah, the science will take care of it, Saina. That's what I'm saying. Generally, heat flows from where to where? Higher to lower temperature, right? So temperature drops. So the science will take care of it. This 1 by A minus X, when you integrate, you'll get one more minus sign. So that will take care of it. So the main catch in this question is people don't understand what to take heat flowing per second. The heat flowing per second is all the heat that is produced from A to X is passing through the thin section dx. That is the main catch in the question. And every section, if you see, right, the more you go outside, more heat is being produced. By the time you reach the outer surface, maximum heat is coming out. So till now, we never faced a situation like that. Until now, in all the questions, current was always constant. So here, heat flowing per second is not constant. A similar, we didn't do the similar question, but if you see in heat transfer, in these questions, right, the current was always constant. Kuch bhi change karo, the current was constant. This never changed. dq by dt. In this question, dq by dt itself is getting messed up. You should definitely try this on your own again. It's a good one. So this is how they can frame pretty good questions on this. If you combine heat transfer and thermodynamics with this, questions become deadly. If you see, actually, there's only I square R. Other than that, current is over. The whole question looks like heat transfer and radiation. All clear with this? Let's see something else. Any doubts on this? Any step you're not clear, please ask. Great. Next thing, maximum power transfer theorem. So we have an internal resistance, we have a battery, and you're connecting it to a capital R. So the question is, now you can't eliminate that small r. So the only thing you have in your control is your capital R, which you can change resistances. So variable external resistor. So the question is, how much should I keep the external resistor so that I can extract maximum power? That capital R could be your fan, bulb, or something. R is your internal resistance, which is constant. That you can't change. So the question here is, so what is the current? So I is equal to E by R plus R. So what is power in the external resistance? The power in R external is I square R, which is E square capital R by R plus R whole square. You want to maximize this. So dP by dr equal to 0. When you solve this, you end up with R is equal to R. When the external resistance is equal to the internal resistance, you get maximum power. When R is equal to small r, we get max power in external resistance. And the sad part about this is, when you take R is equal to R, means half of the energy is wasted in the internal resistance and half of the energy is wasted in the is coming out for the external resistance. Meaning no matter how much you try to do, you can't get more than 50% efficiency. You'll always lose at least 50% energy in the internal resistance. That's what this is trying to say indirectly. So when you are taking energy from a battery, you can't get more than 50%. Have a look at this. So straightforward thing, maximum power transfer theorem. If you put an external resistance, what is the maximum power you can extract in the external resistance? All the heat produced in small r is wasted. All heat in that small r, internal resistance is wasted. You cannot extract that. So that is gone. And you can't change that small r ka value also. So here small r is constant. Clear with this? Let's see a question on this. Let's see a question on this. This is a good one. So we have a battery, we have internal resistance, we have one more resistance, we have capital R. So this is R, this is 3 ohms, this is 2 ohms, and this is 5 volt. So the 2 ohm is the internal resistance. This whole thing is a setup. So 3 ohms and capital R both are this thing, external. So the question is, find R for max power in R. Exam mein they'll ask you this. Find R for maximum power in 3 ohms. Both are completely two different questions. Get them? Try everyone, I'll give you a minute. The people who remember the maximum power transfer theorem, they will simply put R is equal to 5 and come for the second part. But you forgot, there's a word I wrote. When R is equal to R, the maximum power in R. If you want maximum power in your own resistance, then your resistance must be equal to that internal resistance. But the second question says find R for maximum power in some other resistance. You can't use the maximum power transfer theorem. Right, you got a minute. Now see, for the first one, what is the current? 5 by 5 plus R. So power in R would be I square R, which is 5 by 5 plus R whole square into R. So if you solve this, dp by dr equal to 0, you'll get R is equal to 5. Meaning simply the R will think that 3 and 2 are one resistance. The Kepler doesn't know who is internal and who is external. But the second part, current I is again 5 by 5 plus R. So the power in 3 ohms would be 5 by 5 plus R whole square into 3. There is no R in the numerator. So for max power, R should be 0.
And I got
Don't
that
keep-
answer and then I didn't send it to you, thinking it was wrong.
You should send it. Maximum, what would happen? It would have been wrong, bus. But if you had got it right, that would have boosted your confidence. If you got it wrong, you would have learned why it went wrong. This is something I keep telling. In the exam, if you solve a question, and if the answer is there, you should mark it and come. Because two things will happen. Let's say, first possibility, you didn't mark the question and it becomes wrong. You'll feel very happy. Good thing I didn't mark, negative mark nahi aaya. Now you're telling your brain it is good to leave questions because you'll get negative markings. And you're also telling your brain I don't trust my own subject, so I can leave questions. Unfortunately, it becomes right. Now you'll regret it. Shit, re mark karna chahiye tha. So either way, you're losing only. But imagine you marked it. If it becomes wrong, you'll start thinking, yaar, why did this go wrong? Now you're not happy about it. You will actually go and find out why it went wrong. You will learn. If it becomes right, you'll think, yes, you're telling your brain, I should trust my subject. Marking is the right thing to do. That's why you mark it, not because it is, you'll get negative mark or wrong answers. I'm telling you, when you go to an exam, go with you should be very objective there. Why are you doing this? Because it's the right thing to do. I don't give a damn about your feelings. That is what you should say to yourself. Problem is you go to the exam and you become emotional. And that is when you lose your calm and you don't understand what the hell is happening in front of you. You start panicking. I know it's very easy to say, but when you practice this every exam, right, it becomes a habit. And you study so much, right? Meaning at one point, I used to have that physics when I used to solve a physics paper. If I didn't get, let's say, first question, second question, third question, what I used to think? Paper is tough. Even if I didn't get these questions, no one must have got it. That is okay. Let me do the rest. Yeah, alag level arrogance and confidence. If I didn't get it, no one must have got it. Reverse, max mein alag hota tha. I didn't get first question, second question, third question. I said, obvious na. Anyway, I won't get it. Itna to pata hai. Let me try for something easy. So I was always a contradiction. I had both the types of confidences with me. Physics used to put me in sky and maths used to put me in the ground. So that is there. So be careful with this question. It's a good one, it's a simple one. Most people, they'll ask you the second question. People write the answer for the first one and come. Because sabko itna hi yaad hai, maximum power transfer theorem. R is equal to R. You don't bother like what is that, why is that and all. The second thing, bulbs.
We'll use it, but there's one way, like we can take R plus 2 to be internal resistance and then we take it, then
Sir, I thought the same thing.
Then you are again forgetting the question. You proved it for what? Find the value of R for the maximum power in R, where R is a variable. The moment you say 3 ohms, you are giving me the value of 3. Variable kahan pe hai, God? Are you getting the point? That formula was derived for a variable resistor. Here, when you say 3 ohms, you are giving the value of 3. Are you getting the mistake?
So even then, if we want to find the maximum power in 3, it should think that
That's the
I
reason,
divided
na? Suno,
internal.
that is the reason, right? I didn't use maximum power transfer theorem. मैं चुपचाप differentiate करके prove किया. I didn't use a single time here maximum power transfer theorem. I solved it. So check kar lo. How did we get the maximum power transfer theorem? From differentiation, right? There I proved it. You're not getting it here. So all the point about this question is don't blindly write the answer R is equal to R. Be very clear what he is asking. Are you asking find R to find maximum power in R? Then fine. Are you asking find R to find maximum power in some other resistance? Don't use that formula. Clear? That much keep in mind. Next thing is bulbs. So what's a bulb? Bulb is basically a resistor. So generally, right, we give a rated voltage. They say like this: the bulb is 220 volt, 4 watts. When you go and buy a bulb, now you'll see like this: 220 volt, 10 watts, 220 volt, 20 watts. The meaning of this is, if we give 220 volts, we'll get 4 watts of power. That's it. That's what it means. So indirectly, you are getting the resistance. So P is equal to V square by R. R is equal to V square by P. So here V is called the rated voltage. Generally, all our circuits work at 220. So when you go to a shop and ask me, right, give me a 100-watt bulb, no one will ask you what voltage you want. Clear? So this is one. So example, let me show you this. So let's say you take a bulb, 220 volt, 4 watt ka bulb, but you connect it across 110 volt. What happens? So first of all, what is the resistance? 220 volt square by 4. So power in the bulb is V square by R, but we are giving 110 volt square by 220 square by 4. You get 1 watt. Making sense? Means the bulb won't give 4 watts, it gives you 1 watt of power. The bulb won't glow as bright as the before. So this is the meaning of this. Whenever someone says the bulb ka voltage is 220 volt, 4 watt, this is what they mean. It doesn't mean if you keep 440, it will blow off, or 110, it will stop working. Any voltage, it will work. But at 220 volt, you will get 4 watts. If you go to US and try to buy a bulb, there everything is rated as 110 volt, 10 watts. Getting it? So if you're buying bulb in India, right, you don't ask, you simply go and say, give me 100-watt bulb. So it is assumed you are going to use it in India and you're going to put 220 volt supply. You take the same bulb and go and use it in the US, that doesn't work. You won't get the 100 watts, you get something else. That's because the voltage supply is different. Clear with this? That's it. Bulbs, that is the main idea there. Let me show you a question how it works. So let's say we have a bulb here. We have a bulb here. We have a battery here. This is 220 volt, 4 watts. This is 220 volt, 2 watts. This is bulb A and bulb B. Find the ratio of brightness, or find the ratio of power. Or you can say which bulb glows brighter. Find the ratio of power of A and B. Now see, I just want the ratio, so I don't care about the exact values. The voltage could be anything. This is 220 volt, 4 watts. 220 volt, 2 watts. 220 volt, 4 watts. This is bulb A, bulb B, bulb C. Same thing, find the ratio of brightness of ABC. Let's get this thing. Simple question would be, which bulb would be the brightest, A or B? I'm asking you ratio, so that is even better. Let's see the first one. Now see, when you solve these kind of questions, right, forget about the bulb, forget about the voltage, just look at this. What is the resistance of A? 220 square by 4. So if I call this R, what is resistance of B? 220 square by 2. So this should be 2R. So indirectly, what you have given me is a circuit with two resistors, R and 2R. Since both of them are in series, the same current flows. So power in A is to power in B. Now I don't care about I ka value also, because all I want is a ratio. I square R is to I square 2R. 1:2. Bulb B will grow brighter. Clear? So just replace the bulbs with resistor. And since you want ratio, it doesn't matter. Let the current be I and then finish it off. Same thing you can do for this guy also. Try. I'll give you a minute for B. Again, you start the same way. Let this current be I, split the current and finish it off. Lakshika, I think that is right. Try everyone. See this thing. So again, let's replace the resistors here. So RA would be 220 square by 4. If I call this R, then RC also is R and RB is 2R. So just replace the whole circuit with resistors. It will become easy for you to see. So this guy is become R, this guy has become 2R, and this guy has become R. Now, if you send current I, we know the current will split in the opposite ratio of resistances. This is I by 3 and this is 2I by 3. Like I said, I really don't care about the value of current. All I want is a ratio. So power of A is 2, power of B is 2, power of C is I square R is to I square by 9 2R, 4I square by 9R. This would be 9 is to 2 is to 4. That is a ratio of brightness. This is how you do bulb questions. Replace them with resistors. Find the current and finish it off. Clear? Now in this, there is one more way of asking this. Any doubts on this page, please ask. Now in this, let's say something happened and the bulb C got fused. Matlab bulb C got, meaning it became an open circuit. That is, it becomes an open circuit. Now the question is, what happens to brightness of A and B? When bulb C is there, there is some brightness. If C gets fused, what will happen to the brightness of A and C? Increase, decrease, remain same. A and B. You're getting, meaning the circuit has become like this. But C ka thing is gone. The wire got burnt and circuit became open. So you have to compare. I'm not asking between A and B. I'm asking A before burning out and after burning out, B before and after. I hope that question was clear. Try think for a minute. It's a good one. A remains same, B will increase. Okay. A becomes dull, B becomes bright. The catch is this. Initially, when you're finding the current, what is this current? What is R equivalent here? 2R by 3, that is 5R by 3. So I was 3V by 5R. Now in this case, this resistance is R and this is 2R. Current itself changed. I dash will be V by 3R. So for A, what is the initial power? I square R, so 3V by 5R whole square R. You can just look at the current. What happened? Current increased or decreased? And P final is V by 3R whole square into R. You can clearly see P initial is greater than P final. A becomes dim. That is 0.6 current. This is 0.33. Are you getting this? The current dropped in the thing. What about B? P initial, it was V by 5R whole square R. P final, it is V by 3R whole square R. यहाँ पे P final increased. Current increased in B actually. B becomes bright. So you have to compare the currents. This would be a much better question. So you're not comparing A and B. You're comparing A before and after, B before and after. Is this clear, everyone? So there, in heat produced, these are the type of questions. One is the heat produced in the resistor, then you have bulbs, and then you have maximum power transfer theorem. So especially when they ask you heat produced, these things will be related to thermodynamics, like calorimetry and all that stuff. If they want to make tough questions, that is the only way. And before that, we saw combination of batteries. In that, especially the mixed one is very important, and the two batteries formula is important. So this is one part of the thing. So after this, next thing what we have is instruments, ammeter, voltmeter, potentiometer, and all that stuff. The potentiometer is removed from the mains portion. Advanced maybe it is there, right? We will not know until this November or something, December, till the portion comes, but we will do it. So I think that should take another class. So next class mostly we'll wrap it up. Maybe it will spill over a bit. And this Friday we don't have a class. Like I know you guys have a major test on. Most of you have a major test on Saturday, Sunday. So do prepare. So whatever doubts you have, you can send me by Thursday. Like the thing is.